Now we have seen the expansion of binomial theorem, and we have seen how individual terms contain the combinatorial coefficients, that is NC0, NC1 and so on. Now there is another interesting way of remembering how these coefficients come and how they are related with each other, and that is given by what is called as a Pascal's triangle. Alright, let's see what it is. Let's begin with writing the familiar binomial expansion starting with a plus b raised to 1, right? We know that it is nothing but a plus b itself, so I'm just writing it purposefully, keeping the space. Then a plus b the whole square, we know that it is a square plus 2ab plus b square. Then let's write few more. A plus b the whole cube, that is a cube plus 3a square b plus 3ab square plus b cube, and so on. Now if you see the coefficients of the individual terms, once again they are 1 and 1, then 1, 2 and 1, then 1, 3, 3 and 1, and so on. So let me write only the coefficients once again on the right side. So in the first row, when n was 1, we started off with 1 and 1. Then in the next row the coefficients were 1, 2 and 1, and next we had 1, 3, 3, 1, and so on. Now let's try to figure out if there is any pattern in these numbers, so that which will help us to write the coefficients in a plus b raised to 4 directly without using the actual expansion formula. Right, now here we observe that if we add the two successive numbers, we will get the answer as the number in the next row, and the ones on the left extreme and right extreme are to be carried forward. So therefore now if you see 1 and 2 added gives us 3, similarly 2 and 1 added gives us 3, and so on. So with this we can easily find out what will happen in the next row. You see that the ones will get carried over on left extreme and right extreme, then 1 and 3 added gives us 4, then 3 and 3 added gives us 6, and 3 and 1 added gives us 4. So interestingly here we have already observed and found out the coefficients in the expansion of a plus b whole raised to 4. So now all we have to do now is write the terms involving a and b, and we know that in case of a, the degree is going to start with the highest and then going to reduce by 1 and then finally vanishing, and in case of b it is nothing in the beginning, so we may write b raised to 0, or no need to write that. Then the b will start appearing as b, b square, b cube, and lastly b raised to 4. Right, so that's the interesting thing that is called as Pascal's triangle. With this we can also go ahead and write the coefficients in the expansion of a plus b raised to 5. Okay, so these are the coefficients in the expansion of a plus b raised to 5. There are a lot of interesting hidden structures and patterns inside these Pascal's triangles, and some of this we will see later when we study the properties of the binomial coefficients.